So here I'll use the letters B and G to represent the number of boys and girls here. So B is greater than 10. And after 40% of the girls left the class, which means you have 0.6 G remaining. That's the number of girls. And here 40% and 60% of the boys left, which means 40% of the original is the number of boys left. The condition is that the remaining number of girls, 0.6 G, is 8 plus the remaining number of boys. So that's our first condition. So I will clean this up, multiply by 10. So 80 plus 4B divided by 2. So that's our equation. And we also know that B is greater than 10, and these values have to be also integers. So 0.4B is really 2/5 B, which means B can only take on integer values that are multiples of 5. So B could be 15, 20, 25, 30, so on and so forth. And since we're looking for the minimum possible value, we'll see what's the least value of B that's a multiple of 5 that would give us G as an integer. So G is 40 plus 2B over 3. So if we do 15, 15 times 2 is 30, 70 over 3 is not an integer, so it can't be 15. If we do 20, that would be 80 over 3, again, not an integer. And then if we do 25 for B, that's 90 over 3, which is 30. So that one works. If B is 25, G is 30. And you'll notice that this also, G also has to be a multiple of 5 because the remaining is 3/5 of G. So G value has to be a multiple of 5, which is the case here. So that's our least possible value of B and G that satisfy that not only these are integers, but also this condition. And we can test it. If we have 25, it always pays to test the final answer, is that 40% of the girls left the class. So 40% means 12 left the class, so 18 girls are remaining. And then 60% of the boys left the class. 60% of 25 is 15, which means 10 are left. And the number of girls is indeed 8 more than the number of boys. 10 plus 8 is 18. So the minimum possible number is the sum of these two values, which is 55. And that's the answer.